Okay, last up for section 8.2 is topic 4, where we're going to write a trigonometric expression as an algebraic expression, okay? So there may be times where you have to take a trigonometric expression and write it as an algebraic expression. It's a little weird. It's not the worst thing ever. Just know that when we talk about an algebraic expression, we mean no trig functions. So we need to find a way to rewrite an expression without using sine, cosine, tangent, cosecant, secant, or cotangent. Okay? So for example 4, it says, write each of the following as an algebraic expression containing u being the variable that we're going to have here. So like I said, they're a little weird. It's not like the worst thing ever. It's just kind of strange. Okay? It's going to feel strange, but it's really stuff that you already know how to do. So it's not like you're really learning anything shockingly new. Okay? So for part A, we have cosine of inverse tan of u. So let's talk about inverse tangent of u, okay? Remember, inverse trig functions operate on ratios and have output values that are angles, okay? So we can basically say that inverse tangent of some ratio u, and I'm going to go ahead and call it u over 1 so we have a distinct numerator-denominator ratio. This is going to equal some value for theta. It's going to equal some angle. So what we can do at this point is we can be like, okay, well, that's cool. We know that inverse tangent of u is really just an angle theta, so we can rewrite this for now as cosine of theta, okay? So we're just going to kind of rewrite our expression here. But we still have to acknowledge that we need to come up with some way of coming up with a ratio for cosine based on this angle that we know inverse tangent of u over 1 gives us, okay? So let's think about this. Inverse tangent, we should hopefully be really familiar with at this point. It has a range restriction of negative pi over 2 to positive pi over 2. Okay, so that means we're limited to quadrants 1 and 4. Okay, and if we look at this input value, remember when you're dealing with inverse tangent, the input value is some ratio, and we know that tangent has positive ratios in quadrant 1, but negative ratios in quadrant 4. So that means when we draw this triangle, because we're going to go back to this idea of drawing a triangle, we need to draw a triangle in quadrant 1. Okay, so let's go ahead and erase this image right here, and we're going to draw our triangle. Okay. So we need to draw the angle theta. All right. So I'm going to do it in red. So standard position, we should be like real good at drawing these angles. So we've got this angle theta. Okay. Now this angle theta, we can create this little like reference triangle. So we know that we've got this tangent ratio that's u over 1. We've got this angle theta. We need to build this ratio into this triangle. So tangent. Tangent, you have to remember, is always the opposite over the adjacent when we're talking about the ratio of sides. And we know that tangent of theta in this case is really u over 1. So that tells me that when I'm drawing this triangle, theta, okay, the side opposite that has to be u, and then the side adjacent to theta has to be 1. So now we need to use the Pythagorean theorem to figure out what the hypotenuse is, because we're going to need the hypotenuse when we go back over here and talk about cosine, okay? So we're going to call the hypotenuse c squared like we always do. So c squared is 1 squared plus u squared, because that's a squared plus b squared. So c squared is, well, 1 squared is just 1. U squared, we're just going to keep it u squared. And then if we take the square root of both sides, we get that c, the hypotenuse, is the square root of 1 plus u squared. So that is this length right here. All right. And we needed that. We needed theta. Oh, sorry. We needed to draw theta, and we needed to understand the relationship between theta and tangent, because remember, the input of this entire original expression was inverse tangent of u. Okay, so we've got our triangle, we've got our theta, we've got the ratios, everything is good. Now we need to ask ourselves, well, what is cosine of theta? Well, we're talking about this same theta over here. And remember, cosine is equal to the adjacent side over the hypotenuse. So cosine is going to be 1, that's the side adjacent to theta, over the hypotenuse, which is the square root of 1 plus u squared. So now I've taken this original trigonometric expression, and I've got it down to where it's no longer trigonometric. We've definitely gotten rid of all the trig stuff. We just need to rationalize it at this point. So to rationalize it, we just multiply by the square root of 1 plus u squared. We're going to do that on top and bottom. And that's going to simplify to just 1 times the square root of 1 plus u squared, which is just the square root of 1 plus u squared. And then the square root of 1 plus u squared times itself is just going to equal the radicand. So the denominator is 1 plus u squared. So we took cosine of inverse tangent of u and we have rewritten it as an algebraic expression. Okay? Now we get to do the same thing, but with cosine of inverse cotangent of u. So please remember that when we look at this innermost function, so inverse cotangent of u, remember the inverse trig functions operate on a ratio and they have an output value that is an angle. So we know the inverse cotangent of u is going to be some angle theta. And I am going to go ahead and write my ratio. I'm going to go ahead and write it as u over 1 so that I have the distinct numerator and denominator. We'll need that in just a minute, okay? So because inverse cotan of u over 1 is going to be some angle theta, we can rewrite this expression and just say essentially what we're doing is we're finding cosine of theta because these two things are equal. So kind of hold on to cosine of theta for just a bit. We'll come back to it. For now, let's draw this angle theta. So let's think about inverse cotangent. So when you're dealing with inverse cotangent, it has a range restriction of 0 to pi, okay? So 0 to pi. Now, if we're looking at quadrants 1 and 2 here on our unit circle, cotangent has ratios that are positive in quadrant 1, but negative in quadrant 2. And this u right here we were given was positive. So we need to draw a triangle. So we're going to draw this angle theta in quadrant 1, and we're going to build a triangle based on that. Okay, so we're going to draw this angle theta, we're going to draw the triangle, we're going to find the ratios, or we're going to basically use the ratio for cotangent, this u over 1, to find the missing sides, and then we can go back to cosine. So that was a little wordy, a little jumbled, but let's do it. So let me erase this picture, and we're going to draw first our angle theta. So we know this angle theta needs to live in quadrant 1. So when I draw my angle theta, I'm going to draw it in standard position like so. So this is theta. And from this, let's build a right triangle. So we're going to build a right triangle like so. Now, when we're dealing with cotangent, you have to remember that cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, which makes cotangent adjacent over opposite. And we know that cotangent has a ratio of u over 1 for this original expression. So the side adjacent to theta has a length of u, and the side opposite of theta has a length of 1. And so now we need to figure out what the hypotenuse is because we're going to need the hypotenuse when we go back to cosine. So we're going to call the hypotenuse c squared. So c squared is equal to a squared plus b squared. So c squared is going to equal u squared plus just 1 because 1 squared is 1. And then when we take the square root of both sides, we get that c is equal to the square root of u squared plus 1. And now we have our angle theta. We've used this ratio that we were given with inverse cotan, which was u over 1. We've put that in here. We've built the triangle. We found all the missing sides. And now we can figure out what is cosine of this angle theta that we have drawn. Well, remember, cosine is adjacent over hypotenuse. Well, the side adjacent to theta is u. The hypotenuse is the square root of u squared plus 1. And now we've taken all of the trig functions out of this expression. And if we can rationalize this final line right here, we've got our expression. So we're going to multiply top and bottom by the square root of u squared plus 1. When I do that, that's going to make my numerator u times the square root of u squared plus 1. And then my denominator, when I take the square root of u squared plus 1 and I multiply it by itself, I'm just left with the radicand u squared plus 1. And that's it. So it's a little trippy, it's a little weird. You have to be really mindful of like, what is my input function? In both cases, our input function was an inverse trig function. So we had to acknowledge that inverse trig functions have outputs that are really angles. So essentially, we're taking this cosine of some angle But we have to use the inverse trig function that we were given to build the angle theta, the resulting right triangle, and so forth. So some weird steps, a little wacky. Again, this is not something that's going to come up loads and loads and loads and loads and loads and loads in your life, but you do need to understand how to take a trig expression and rewrite it as an algebraic expression. So there you have it. All right, 8.2 is a weird section. All right, these inverse secant, cosecant, and cotangent functions are a little strange, but I have complete and utter faith in you, and I think y'all got this.